Another puzzle that's baffled the scientific community for decades is superconductivity. When various solids are cooled to extremely low temperatures, they can conduct electricity without losing energy. This happens because the freezing temperature allows electrons to move slowly enough to overcome their natural repulsion with each other, and they begin to form pairs. Like any good couple should, they balance each other out and begin to move in the same direction. When this happens, electrical resistance disappears. This is what makes superconductivity the holy grail of energy efficiency, if only scientists could overcome the limitations of temperature. This is Ranga Dias. This year, he and a team at the University of Rochester created a metallic compound that for the first time exhibited superconductivity at room temperature.
So you have a very small two diamond tips that's sitting opposite to each other, and then you put your sample that you need to study in between those diamond tips. So you can apply force mechanically.
Dias's team applied pressures almost as extreme as those found at the Earth's core. They did this by crushing the compound inside a microscopic niche they carved out of a diamond anvil. Then they triggered chemical reactions with a laser beam.
So that way, we were able to really find the room temperature superconductor. You know, it's under pressure, right? What we have found is under pressure. So somebody can argue that, okay, so you went from one extreme to another extreme. So who cares? So, you know, what's a big deal in that sense, right? But I think there was a time that we were, even the scientists were thinking that room temperature superconductivity is not possible. To be honest, the very first time when we saw this one, I didn't really believe it. And I was like, okay, this is too good to be true. And why we are seeing this nice resistance. Everybody around the world contact me via email or phone calls, and they were very excited. And this is a landmark discovery. But there are a lot of work to be done because even though we know the initial composition, you know, what are the material that we put together to pressurize it, but we don't know actually what it is really, what the sample is superconducting. So that those studies need to be done.
So for now, levitating trains, lossless power transmission, and perfect energy storage are still utopian dreams. But Dias believes they're not far off.
I would say I'm very optimistic. Probably in the next 5 years or 10 years, may be able to get to a real application.